otherwise minus d e gravitational over dr is equal to f gravitational. With the inclusion of the gravitational interaction between the object and the gravitational center, the energy balance reads m0 half r dot squared plus E of r is equal to m0 halves times in brackets V total plus 1 over m0 c times qe over 4 pi epsilon 0 r squared minus m0 half c squared plus gn m0 m sun over r is equal to m0 times in brackets bracket V total plus 1 over m0 c times qe over 4 pi epsilon 0 r squared minus c squared bracket 1 minus 2 gn m sun over c square r. Here the energy function E gravitational is actually retrieved from the general energy function E of r on the left side of the balance. That is to say, it enters the balance linearly. This is contrary to the entry of the energy function E electric in the balance as a squared term. The difference basically is related to the fact that in the electromagnetic interaction the photons have to interact with two bodies in order to establish the connection. Contrary to this, in the case of the gravitational interaction, the interaction is already established when the graviton coming from one object reaches the other body and sticks to it. Thus, the gravitational interaction is quite a sticky thing, and its effect merely is retrieving energy from the energy reservoir that can feed the kinetic energy of the object. It is still possible that the gravitational field of the object interacts with the electromagnetic field of the gravitational center. For this interaction, the dynamical self-energy of the electromagnetic field of the charged gravitational center is E field is equal to minus q squared over 4 pi epsilon 0 r times the square root of 4 pi. And the dynamical self-energy of the gravitational field of the object is E g field is equal to minus gn m0 squared over r times square root of 4 pi. The factor square root 4 pi stems from the fact that the self-interacting fields are monopole fields, where radial field lines are stretched out on the surface of a sphere A equal to 4 pi r squared. This is different to a field that interacts between two bodies, which is a dipolar, and where the field lines can be thought of being distributed only along the straight connection line between the bodies. Hence, one has to substitute r prime equal to square root a equal to square root 4 pi r, equivalent r is equal to r's prime over square root 4 pi in the expressions of the dynamical field energies. This gives equation 31 and 32 if one drops the prime again. Since the electromagnetic field of the gravitational center moves with the momentum p equal m0c with respect to the object, and p equal m0c is also the momentum of the gravitational field of the object in the rest frame of the object, we get VE field is equal to minus 1 over m0c q squared over 4 pi epsilon 0 r times square root 4 pi, and VG field is equal to minus 1 over m0c times gn m0 squared over r times square root 4 pi. For the dynamical velocities of the electromagnetic field of the charged gravitational center and the gravitational field of the object. Thus we get E dynamical Eg is equal to m0 half VE field times VG field is equal to m0 halves 1 over m0c times q squared over 4 pi epsilon 0 r times square root 4 pi times 1 over m0c gn m0 square over r times 4 pi is equal to m0 halves c squared 8 pi gn over c to the power of 4 times 1 half times q squared over 4 pi epsilon 0 times 1 over r squared. As the dynamic energy of the interacting electromagnetic field of the charged gravitational center and the gravitational field of the object. Note that this expression has a similar structure as E dynamical equal to m0 r dot squared halves for the dynamical or kinetic energy of the object, where the velocity field of the object interacts with itself, so to say. The energy balance now reads m0 halves r dot squared plus m0 half c squared 8 pi gn over c to the power of 4 times 1 half times q squared over 4 pi epsilon 0 times 1 over r squared is equal to m0 halves times in brackets bracket v total plus 1 over m0 c times q e over 4 pi epsilon 0 r squared minus c squared brackets 1 minus 2 gn m sun over c squared r, which is equivalent to m0 halves r dot squared is equal to m0 halves times in brackets bracket v total minus 1 over m0 c times minus q times e over 4 pi epsilon 0 r squared minus